Alright everyone, what's going on? Mr. D'Souza here. So I heard that you have a quiz on Thursday. Okay? So I heard you had a quiz on Thursday, and you know what? Let's just do a review, right? So what I'm going to recommend is that the questions that are in this video are very, very, very similar to what you're going to see on Castle Learning. Okay? So I would strongly recommend using this as a resource when answering those questions. Okay? I'm going to kind of summarize a lot of the stuff that you learned. I'm going to do different types of questions that you're prepared. So let's just jump into it. Alright, so you learned a lot of different types of graphs this entire school year. So let's go over how to identify some graphs. So the first one is just a straight line. This is a linear function. Linear functions are straight lines. If you see a function that looks like a U, now it could look like that, or it could look something like this, right? It could be a U like that. These are called parabolas. But the function is called quadratics, right? They're quadratic functions. Okay? The next one. It kind of looks like a quadratic, but it comes to a point. It's a V, right? And functions that, when you graph them, they look like a V, are absolute value functions. This is what you learned this week. Alright, let's look at these graphs. What are the only other things that you learned? Exponential, right? So this one on the left is going from left to right, it's going down. So this would be exponential decay. And the other one, if you're looking at the graph from left to right, it goes up very fast. So that's exponential growth. Okay, so let's do some exponential growth and decay problems. The equation v of t equals 25,000 times 0.55 to the t power represents the value of a car t years after it was purchased. What does each part of this equation represent? Okay, so v of t is the value. So v of t is the value of the car after t years. That's literally what it just explains, right? Alright, now the 25,000 represents, remember, it's the coefficient, that's our principal, right? So remember, exponential looks like this. Okay, so exponential functions look like this. The only difference between those two functions is the one on the top is a plus for growth, and the one on the bottom is a minus for decay. So depending if the question is talking about growth or decay is how you choose which function you're going to use. So, P, remember, stands for principal. It's the original amount. So if this is talking about the depreciation value of a car, 25,000 is the initial amount of the car. Okay, and the 0.55 is that stuff inside the parentheses. That is our growth factor. Remember, if the growth factor is greater than 1, it's a growth exponential function. If it's less than 1, that means it's decay. It's decreasing in value. Okay. And then lastly, t is time. So some questions like to ask, like, well, what does 25,000 represent? What does 0.55 represent? You need to remember what P, R, and T represent, right? The initial P. The stuff inside the parentheses is the growth factor. Is it growing or decaying? And T is time. Okay, so this is kind of like a similar question. The following function, f of t, equals p times 1.750 to the t power, where p is the initial amount of money in the bank over 2 years. What percent is my money increasing each year? Interesting. We're talking about increasing, which means we're talking about exponential growth. So that is going to be A equals P times 1 plus R to the t power. Now we are trying to figure out what the percentage is increasing. Now some people are going to think that the number inside the parentheses, you just got to transfer that into a percentage and you're done. But that's not true. The rate is what you're looking for. The rate is what you change into percent. But to get the rate, you have to set your growth factor equal to 1 plus r. Because we're doing exponential growth, 1 plus r equals 1.750. I'm going to solve for r right now. But here's the issue. Now that I have r, that's a decimal. They want percent. So how do we change a decimal to a percent? Yeah, you move the decimal place over 2 times to the right. So our answer, 75% is increasing each year. Okay, Mr. Vesia opened up a retirement account with $40,500. His account grew at a rate of 7% each year compounded annually. That is amazing. He made no deposits, no withdrawals in the account. At the end of 20 years, what is the account worth to the nearest dollar? So essentially, my friend Mr. Vesia, he threw a bunch of money into an account that grows 7% each year. He wants to know if he doesn't touch it, after 20 years, what happens? This is exponential growth because it talks about how his account grew. So let's write exponential growth. And let's fill in what we know. The original amount of money that he put in the account was $40,500. That's our principal. Now the rate is that it's 7% each year, but you can't substitute in 7% because your rate has to be a decimal. So if we have 7% here, how do you make that a decimal? Yeah, just move the decimal place over to the left 2 spaces. So 0.07 is our rate. Now, t represents the amount of years. Well, how many years does he want to know? 20 years. Now, if we put all this in our calculator, whether if you want to use your phone or a calculator, you're going to get your answer. Let's see what we got. So, at the end of 20 years, this is what I got. So, rounding it to the nearest whole dollar, I got $156,722. That's the answer. Okay, so graphing absolute value functions. So, what we do is the following. You can use your graphing calculator. That'll probably be the easiest thing. Or you can use, you can just write out a table and plug in some points. I would say use a graphing calculator. Miss James posted where you can get a free graphing calculator app on your computer. So I would check that out. So let's just do that. Okay, so all I'm going to do is put in y equals the absolute value of x plus 1 on my calculator. So I'm going to go to y equals. I'm going to click math. I'm going to go over to number using the right arrow. ABS stands for absolute, so absolute value. You're going to click enter. I'm just going to type this in. X plus 1. X plus 1. Second graph is going to get me my table of values. So let's just put this in. So what Miss Fu taught you is that you kind of want to look through your table to see where there's kind of like a symmetry. Okay, so I'm going to scroll through. Okay, so do you see that right here, -1, 0, if I go up, it goes 1, 2, 3. If I go the other way, it's 1, 2, 3. So I know that because this -1, 0 is my, it's going to be a minimum point. It's going to be the lowest point. It's going to be that point of the V. Then I'm going to choose just any 2 other points to the left and to the right so that I can connect. So I'm going to use -1, 0. And I'm going to do, let's say, -3, 2. And let's just do 1 and 2. Okay, so we got -1, 0. So -1, 0. negative 3, 2, so 2, 3, 1, 2, and then 1, 2, 1, 2. I'm going to connect. I'm going to put the arrows at the end of my graph because I know it goes on forever in that direction. And there you go. That's how you graph it. Okay, so let's talk about graphing some inequalities. So let's say I wanted to find the equation of this line. Okay, let's just ignore that it's an inequality first, and let's just find the equation of the line. So for an equation of a line, you need y equals mx plus b. Alright, that means I need a slope and the y-intercept. The y-intercept is right here. That is 0, 3, so my y-intercept is 3. Now I just need to figure out the slope. The slope, let me just pick another point. Let's choose this one. And remember, you want to go left to right. So what's the rise over run? Well, I gotta go down 1 and to the right 2. So down 1, that's negative 1, and right 2 is positive 2. Okay? So that's the equation of the line, but now we gotta figure out, right, is it greater than, less than, greater than or equal to, less than or equal to? And you should know, because this line is a dashed line, that it has to be either less than or greater than. So you know what? Why don't we just choose one and just test a point and see if it works? So what if I said that y is greater than? Okay, let's test it. Always use 0, 0, so long as 0, 0 is not on the line. So we're going to use a test point of 0, 0. And let's test to see if this point works or doesn't work. If the point doesn't work, then that means we're good because it shouldn't be part of the solution set. So 0 is greater than 1/2 times 0 is 0. So 0 plus 3 is 3. Is 0 bigger than 3? Remember, we tested this point. If it worked, we would shade in that direction. But 0 is not greater than 3. So we need to shade in the opposite direction, which tells us that this is the correct equation. Okay, let's just talk about what solutions to systems mean. When you want to find a solution to a system, all you gotta do, if it's graphically, just find the intersection point. So if I gave you two lines like this, what is the solution? If you said 2, 2, you're correct. That is the intersection point of both lines. That's it. Solutions to systems are the coordinate point that both lines share. Graphically, that's where they intersect. Algebraically, which is what we're going to see in a second, is where the coordinate point satisfies both equations. So let's talk about writing systems. Ms. Fu has 60 coins that total $7.15. All of her coins are dimes and quarters. Write a system that models the situation. So a system, we need two equations for now. So she has 60 coins. So D and Q represent the coins themselves. So the amount of dimes plus the amount of quarters should equal 60 coins. Okay? But now we want to talk about the value of those coins. Well, a dime is 10 cents. So 10 cents is 0.10 times D plus a quarter is 0.25, right? It's 25 cents. And then when you add that together, it should equal $7.15. That's it. That's your system. If you wanted to solve, we could, but it's not asking us to solve. It just asks us to write the system. Okay, so now it says solve the following system for the solutions, right? There are different ways. You can do it graphically. You could do it using substitution or elimination. I see that y is already by itself, so I'm going to use substitution. I'm going to get y by itself and then substitute it back into the equation below. Okay, now I have y by itself. I'm going to substitute y into my other equation. Now, all I gotta do is simplify and solve for x, then substitute back in and solve for y. So we got x is -3, but I need to know what y is. So I'm going to substitute my x back in and solve for y. So I got that y equals 5. Now I'm going to write it as a coordinate point, and then I'm done. Okay, so hopefully this was helpful. Remember, the purpose of this was not to literally reteach you everything, but I wanted to kind of go through different types of problems that are very similar to on your quiz, so that you have some kind of anchor to where it relates to the things that you've learned. Okay, so I would strongly suggest you use this video to help you with a lot of the problems that are on the test. Always reach out. And just a little disclaimer, this doesn't go through everything that's on the test. Like, for example, linear quadratic systems I didn't go over. There's a couple like little minor things, but I wanted to give you a really good resource that you can use to help. Okay? If you have any questions, please reach out, and I hope you all have a great rest of your day. Good luck on your quiz. See you later, everyone.